Hello, everyone. Today we'll be talking about our experience in building an overhead bug bounty program at NVIDIA.io. So I'm Joy, I'm the DevOps and security architect for NVIDIA.io, and with me is my colleague Pankaj, a senior security engineer looking after the security posture of the organization. So we've broken the talk down into multiple parts as a roadmap to walk you through for easy navigation. First, we will talk about why we choose to build an in-house system and not go for SaaS offerings. Then we will approach how we built it piecemeal from both open source software and SaaS products we were already using and paying for. Pankaj is then going to walk you through the structure of this automated pipeline and workflow. We will investigate the pros and cons we encountered while building and using this. Then we'll chat a little about what we have planned for the future and possibly are already building, closing it all with a few tips and tricks we learned along the way. First, the whys and the hows, right? As we all engineering folks know that engineering is an exercise in making assumptions work under certain constraints. And we were hit with certain constraints when we started building the security culture here at NVIDIA. So when we initially started out, the vulnerability reports were already being piped to us via informant channels like mails, messages. It was unstructured, taking up the leadership's time for generating the ad hoc responses. And there was no common playbook on how to essentially reach out to security researchers and answer their queries about some vulnerabilities in parts of our applications. We wanted to formalize this process and bring in a semblance of order to the chaos that surrounded us. Engineering needed prioritized and properly grouped list of vulnerabilities so that they did not have to think twice on what should be the most impactful fix. When Pankaj joined us, we also had a dedicated engineer who would go through the list of known vulnerabilities in our services and classify and rank them properly and report it back to engineering. Let's talk about how we approached in building this and what were the tools and platforms we actually surveyed before even thinking about how to build this. We had two paths to follow, whether we are going to build an in-house program or maybe go with some well-known and crowdsourced vulnerability platforms like BugCrowd or HackerOne. So here we have attached link to most of the well-known bug bounty platforms in the market that are out there. You're free to scan the QR or copy the link from here and browse it for yourself. So we ended up choosing an in-house bug bounty program. Here is the why of it. When we started the security culture at NVIDIA, exposing our applications to a global community of security researchers using the well-known crowdsourced platform would have invited a significant amount of interest and also threat actors onto our platform. This would cause a significant engineering overhead to fix all possible discovered vulnerabilities at scale and within expected turnaround times that these platforms expected us to adhere to based on the severity levels. This was early days, so not all of our applications were internally pen tested for vulnerabilities end to end. We were still building the initial systems to set up our internal pen testing culture and the workflows. So we thought of building an end-to-end in-house pipeline using bare minimal piecemeal tools we already had. We had Google Form, which we essentially made where the person reporting the security issue could fill in their metadata, upload their files or videos that they have taken of the vulnerability. We thought we would store all of this data in a simple Google spreadsheet because, well, to be very honest, most engineering problems can be solved using spreadsheets. Then we had a couple of other things that we threw into the mix. To automate a lot of things on top of the Google spreadsheet, we used the Google App Script. We created a lot of workflows for email responses back and forth with the security researchers using Zapier. And we also connected Zapier to our core issue management platform, which is Linear, and essentially use Linear to not only send emails back and forth to the researchers, but manage the entire lifecycle of the bug bounty program via the issue management platform itself. And finally, we had Slack and Gmail for the notifications, Slack, of course, for internal notifications, and Gmail so that we could communicate to the security researchers who were reporting vulnerabilities. And all of the planning that you are about to see that happened between Pankaj and I to build this out by using a Miro board. This was excellent for brainstorming, rearranging workflows, and understanding where there were gaps and where we could do better or where we could even sometimes do less to make sure the workflow is lean and effective. So with that, I will give this talk over to Pankaj, who will walk you through the rest of the pipeline and talk about our learnings and tips and tricks for the rest of this talk.
Now, I will be discussing the bug bounty program pipeline which we have created. So this is the initial reporting pipeline which you see. The way vulnerabilities at InVideo can be received are in two ways. It can be by an internal pen test by the security team, or by an external submission by a security researcher or a bug bounty hunter. I mainly will be talking about the external workflow here. We have a responsible disclosure page which has a Google form embedded in it, and security researchers can use that Google form to submit the reports. The Google form is backed by Google spreadsheet. So the moment a vulnerability is submitted, for every new row which is populated inside a spreadsheet, a UID is generated using Google App Script. Google App Script is another component which Joy mentioned that we have used here in the integration. The UID we use for all the future communications with the security researcher, also to assign a unique ID to every vulnerability report submitted to us. A linear ticket is also created the moment data is populated inside spreadsheet. The ticket has a formal structure. It has title, severity, technical description, steps to reproduce, POC. It has a section for mitigation and solution, and even the recommendations as well. After the data is populated inside linear, email acknowledgement is sent to the security researcher. That email basically says that thank you for submitting the report, and our security team is looking into it and we'll get back to you soon. And same time, after the email is triggered, a Slack message is also triggered for our internal purpose inside our NVIDIA security Slack channel. Basically, you can say that Slack alert basically gives a brief about the vulnerability report and contains a URL pointing to the linear ticket, so that the security team or who thinks the report is a priority to them, then they can read the report by just clicking on the URL which is present in the Slack message. Complete pipeline has been automated and is handled by Zapier. After the Google form tells Slack alert, there is no human intervention required here. And then comes the security team, where the security team picks up the vulnerability and validates the report. The security team will read up the report, they will try to reproduce the issue, and then they will see whether it is a valid issue, it is a duplicate, or it has already been submitted or not, or it is a out of scope issue. So basically, the reports will have mainly three states. It can be either valid, duplicate, or out of scope. Valid basically means that the vulnerability report is valid and reproducible and has an impact if it is not fixed soon. Duplicate, this means that we already have a similar report, and the first report will be considered as original and will be rewarded, or you can say eligible for a bounty. Talking about out of scope, this basically means that the vulnerability does not fall under the scope of our bug bounty program and will not be considered a valid report. So whenever we receive a duplicate or out of scope vulnerability, the pipeline has similar workflow for both of them. After the validation by the security team, if the report is duplicate, or you can say out of scope, then the security team basically adds a label inside the same ticket created in linear. Linear is just like any other issue management or tracking platform like Jira, you might have heard Confluence, and Asana as well. So, the linear basically lets you add labels, and we have created labels like, duplicate and out of scope. So the moment we add a label, an action is triggered by Zapier, and an email is also sent to the security researcher with a detailed response on why the report is out of scope or duplicate. We also provide, links to our responsible disclosure program, so that, the bug bounty hunters or the security researchers, you can say, they can just go ahead and read the bug bounty program rules. If they do not agree with the email also has a statement which says that if you do not agree with us, you can reach back to us, and we will discuss and we'll reach to a conclusion around that. Now we will discuss about what happens when the issue is valid. So whenever an issue is valid, the internal security team basically recalculates the severity of that vulnerability based on the business impact, or you can say the damage the vulnerability can cause to the organization or the customer of InVideo. The severity is calculated using Common Vulnerability Scoring System 3.1. Whenever an issue is created inside linear from the spreadsheet, from the initial reporting pipeline, then there are few sections which are left as blank. They are like internal security team recommendation, internal severity calculation kind of fields, where the security team does their observation, and then the data is put there as the observation or the severity, which is calculated internally based on the damage it can cause to the organization. So one another reason, to use CVSS is that, it helps the engineering to prioritize the security issues depending upon the severity. To appreciate the time and the effort put by the security researcher, find the vulnerability, we ask the researcher for an invoice. They can basically generate an invoice, and we can reward them according to the severity of the vulnerability. There are times when there is a vulnerability which, the top leadership consider it as a acceptable risk and decides not to fix it because it is required by the product or the feature. In that case, we basically add a label to won't fix, and the researcher gets an email that this is a acceptable risk and this won't be fixed, and the state of the issue is also changed to won't fix. If you see this, there are states like security vulnerability report, valid not fixed, internal revalidation, internal QA, and so on. Whenever a linear ticket is created from the spreadsheet from the initial reporting pipeline, the issue falls under a security vulnerability report. This basically tells the security team that there is a vulnerability report, and the security team needs to validate it. Once the security team validates the report, they can change the state to valid not fixed, which basically means that the issue is valid and it is not fixed yet. We have scheduled basically a bi-weekly security cadence where we discuss about the state of the issue, whether the issue has been fixed, if it is being fixed, or if it has been picked or not, these kind of things. And there are times when the engineering wants to understand the business impact of the issue, or they want more clarity around the particular vulnerability. That is also discussed in that meeting. So let's say that the devs understand the issue and they have gone ahead and fixed the issue. The devs or the engineering, they change the state to internal revalidation. The moment the issue comes inside internal revalidation, the security know that there is a vulnerability which needs to be revalidated, and it has been fixed on staging by the engineering. Security team basically revalidates the issue. If the issue is fixed, it goes to QA. If it is not fixed, then the state is changed to not fixed, which is again, going back to valid not fixed. The vulnerability has been fixed, it goes to QA, and then a label is also added for QA, where QA is informed about this. QA knows that there is a vulnerability which has been fixed on staging and it needs to have sanity checks and all. And if they approve the fix, the issue state is changed to internal fixed. If they do not approve it, it again goes back to valid not fixed. So we already have a internal documentation for reference about this whole workflow, so that they can just go ahead and read up that whole JAPSAC documentation we have created, and they can understand how to work with this whole workflow. Once the issue has been changed to internal fixed, security team again comes into picture, and they basically do a follow-up maybe in the bi-weekly call with the developers. Let's say that the fix has been released on the production. Then in that case, if the vulnerability was submitted externally, which most of the case we have, then we basically ask the researcher for an external revalidation. There is a complete workflow around that as well, where we change the state of the issue from internal fix to external revalidation. And whenever the state is changed, an email is triggered where we ask the researcher whether it is fixed or not fixed. That email contains a small form where the researcher can update the state whether it is fixed or not fixed, and it also contains a description where if it is not fixed, then what they think the reason is, and they can again put a description around that. That particular data is again populated back inside the same linear ticket as part of the comment. If it is not fixed, then again the issue goes back to the valid not fixed. If it is fixed, then we change the state to fixed, and then we update the state manually to fixed. Basically, this is the complete pipeline. You may see this orange arrow which is bypassing the external revalidation. This basically happens when the vulnerability is discovered internally. In that case, it doesn't require an external revalidation. After the internal revalidation, it has been released in production, directly goes to fixed stage. So this is the complete pipeline of how we alert the engineering. The flowchart basically explains the detailed workflow. After post validation, when the issue is valid, the security team basically assigns the vulnerability to the relevant engineering pod for the fix. The security team basically adds a label with the pod name. You might see the different names written here, like backend, editor, front-end, growth, and infrastructure. These are the list of pods. Depending upon the pod name or the label which has been added, Slack messages is sent to in the security channel with the pod leadership name tagged on it. And the message also contains a brief description about the vulnerability and the linear ticket URL, so that the pod leadership knows that there is an issue which falls in their domain, and they can simply browse to that URL which is mentioned inside the Slack message, and they can read up the whole vulnerability report which has been submitted to us. Then talking about the invoicing, basically where we ask the researcher to raise an invoice when we want to reward them as a thank you for finding vulnerabilities in securing their applications. We add a label which is raise an invoice. That label triggers a Zapier action, which basically extracts the internal severity, which is calculated by the security team. The severity can be critical, high, medium, or low, and then that action basically sends an email to the security researcher containing the invoice details, asking for raising an invoice for the amount based on the severity which is being written in the email. Whatever severity is calculated by the security team, the Zapier basically extracts those internal severity and the internal CVSS score, and then it puts that into the email in that template and sends it to the security researcher. When the email goes to the security researcher about raising an invoice, that also contains the finance email address in the CC, so that when the researcher sends an email back to us with an invoice, finance team basically takes over the email. They basically do the billing and whatever action item on their hand, and then they reach to the security team, where security team basically follow-ups again with the security researcher with the reward. What worked for us? So if you ask us, the integration does the job really well. The implementation gives us enough confidence, just like any other well-known bug bounty program. or you can say management platform. Most of the communications between the in-video security team and the external researcher is handled by this workflow. We have created multiple email templates inside Zapier, which is being used for communication at different stages of the program. A good thing is that within less than 2 months, our workflow was set up and we were completely hands-free. Till now, everything we manage inside Linear app with just labels. If you ask us what did not work for us, well, by using this complete pipeline, there are times where we identify a few gaps, but those are not major gaps, and we can live with that. So as of now, we are okay with those gaps. The Zapier integration takes few seconds to trigger the events. Basically, whenever an action is triggered, certain time interval gap you can say between when the vulnerability is submitted via the Google form, it takes some time for the Zapier to populate the same one as a linear ticket. And if you talk about vice versa, then if an action is triggered from the linear code by adding a label, then it takes few seconds to generate an email which is sent to the researcher, security researcher. Thinking ahead now, what are our future plans and what we are thinking ahead about this complete pipeline? Good thing is that this program is completely managed by our security team, and we made the choice of not offloading program management to a third party because the program is completely managed by us. We are not at the mercy of third party when it comes to a report timeline or fixing bugs. This also lets us build the product and fix the bugs depending upon the severity and the org priorities, which is more important to us. If I have to talk about the cons of having an in-house bug bounty program, then the volume of bugs that get fixed by an internal program due to the lack of external pressure is lesser, which we have analyzed at InVideo. What else we are planning? We are planning to set up a complete DevSecOps pipeline. This has been taken as a reference from OWASP DevSecOps guideline V0.2. Basically, at a high level, if I have to talk about it, we are basically planning to put our all the results and the reports of various scans such as secret scanning, code scanning for vulnerabilities, container scanning into an open source security orchestration or vulnerability management platform called Defect Dojo. Defect Dojo is an OWASP flagship project. You may go ahead and scan the QR code to know more about all the tools I have mentioned here. We may also plan to modify our existing bug bounty pipeline where we are populating all the vulnerabilities inside Linear. What we are planning is to put those reports inside Defect Dojo so that all our vulnerability reports, whether it is from secret scanning or whether it is from SaaS or it is infrastructure as code vulnerability scanning, all the results and the reports from the external researchers can be put into one place, and it will be easy for us to manage those reports. Defect Dojo also gives you a metrics around the vulnerabilities inside your dashboard, so that is another advantage for using Defect Dojo. So let's talk about the tips and tricks now. Starting with the first one, prioritization of vulnerabilities to fix and choosing to fix based on the vulnerability impact would be a good idea. At InVideo, we use CVSS score to calculate severity of the vulnerability. Based on the impact, calculated severity is critical, high, medium, or low. Helps you prioritize, fixing of bugs. This also helps developers, to save bandwidth and helps them to focus both on security issues and product features. Having your applications internally tested or maybe tested by third parties for security issues, this will basically help you flag major vulnerabilities before an external malicious actor can find and exploit them to cause damage to the organization. And it will help you develop secure services anyways. I would say automate as much as possible. This will help the security team save bandwidth and will help them to focus more on critical security problems inside the organization. Having a dedicated security engineer who understands threat surfaces or priorities, who can drive the security posture of the organization. To be more specific, automation will bring you velocity, and having a subject matter expertise who can drive the security posture with a certain amount of acceptable risk, which when combined together will help you with fast and impactful security fixes. Thank you all for joining us on this talk and giving us the opportunity to present our own experience of how we ended up building an in-house bug bounty program. Feel free to ask questions. We are here. In case we are not able to answer all the questions, then you can go ahead and find us on Twitter at Pankaj Mouriya, and Joy you can find at Hashfire. So yeah, please go ahead, ask your questions. Thank you.